The forms of a quadratic function. First, we have standard form. Y equals ax squared plus bx plus c. A tells you a couple things. Tells you whether it opens up or down, and it tells you a little bit about the width of the parabola. And then C is your y-intercept. Vertex form. Y equals a times x minus h squared plus k. A tells you the same things as before. H is your x-coordinate for the axis of symmetry. And it is the x-coordinate for the vertex as well. K is the y-coordinate for the vertex. So vertex form, HK is your vertex. Your vertex will be H comma K. Vector form. Y equals a x minus m times x minus n. For this, your x-intercepts are at m comma 0 and n comma 0. So m and n are your intercepts. The axis of symmetry. A couple ways to find that with a parabola. Axis of symmetry is the equation or the line that cuts through the vertex. So it's x equals h if you're in vertex form, or another way to find it is x equals the opposite of b over 2a. You plug in your a and b values from standard form, you will get the equation of the axis of symmetry. The ways to solve a quadratic. One is to factor. Two, graph and see where it crosses the x-axis. 3 is to use the quadratic formula. The of x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So just plugging in your a, b, and c values, you can solve a quadratic. And then the last way is completing the square. You have 0 equals ax squared plus bx plus c. You're going to get the c value to the other side. Then you're going to add b over 2 squared to both sides. And then you're going to factor the side. And it's always going to be b over 2 right there. Squared. And then if we continue to solve for this, we can solve for x that way. Completing the square also is good to get it into vertex form. If we manipulate at this point, bringing everything back to one side. The discriminant used by the symbol delta, looks like a triangle, is what's underneath the square root in the quadratic formula. So the discriminant is b squared minus 4ac. If the discriminant equals 0, then there is a repeated root. If your discriminant is greater than 0, there are two distinct real roots. If your discriminant is less than 0, there are no real roots or no real solutions.